this was not the point we were looking at before. This is another one. Anyway, so here we have the results from the optimization. Save that file, and now I can open it in Simbox instead. The simulation, it was this one. And I need to go to the control table to just define this, that I want to use this set of spare parts in the allocation point identifier, rather than using the current point, which was just 3 of each. I will select that one with number 16 that we optimized with OPUS 10. So, and also, just gonna show you how this works with just one replication. Also shorten the result collection files, and we run this one. So here is the simulate button in Simbox. Press the one. I didn't miss anything. So one replication there. So just to show you how it works. So sometimes it's pretty nice with Simbox to just run one replication, because it helps you understand the outcome in a much more flexible way. Then you run, of course, when you want the final answers, you should run more replications. It took some time here because I limited the result collection to just one. Just 1 hour, so we got a lot of information here in this graph. Right, so if we look at item results, and then I select the stock levels for this is the, I don't know, I think my computer wants to go home or something. There we go, but anyway, we're just going to select the compressor blade, because that's what I wanted to show you. Now we can do time, come on. This is not really normal, but it takes so much time, but now it did. Anyway, so here's what happens with items. We have total, we have overall the basis, we have 47. Yeah. Okay. Anyway, what happens is that we can follow the single item to see how it is the specific items.
That's all items.
Thanks. Thought I clicked the. That's better. Now here we have our 16 items. That looks much better. Thanks, Oscar. Anyway, so what happens from the beginning? We have 16 of these on hand, and you see what happens is that it starts to go down here, and when we reach the somewhere down to 3 here, or what our reorder point was, we will load new ones. But what happens is that we don't really get those before we have even more demand. So you see we have all 15 in resupply here, and we get some more demands, which means that here we actually get some back orders, even though we had 16 on in stock. So you can follow here over time exactly what happens. But then they come in, so we can serve those 6 or 7 demands that we have, and then they continue to get more demands, and then we back down again, and this is how it fluctuates over time. But this is just one single replication, so it's one statistic outcome. But it was just to show you how it goes up and down from 15 on hand, and then they are in resupply, so they are and then we have the back orders. Okay, so that's regarding, and of course we should also turn up the control again if you want to run the real like the real case here. So rather than just doing one replication, we should do 100 instead maybe, and run this. It goes pretty quick still. So that's how it goes, and we can see the average result more here. You see the curve is now much smoother because it's the average value over all the replications. So you see that we do have some back orders, but this is for all items here again. Let's look at the compressible dates. We have our 16 or 17 here on the stock, and you see how it fluctuates, but we still get a more smooth curve because it's we do many replications and then we calculate the average value. Right, I think we take a short break before we do the last session of the day. So let's stretch some legs for a few minutes and then continue. Okay, thanks. We use the previous file as a starting point, the one where we added the reorder of one of the items. And I select Save As, get back in here, and I'll call this one Resources as well. Okay, so now we have another file, and I can add data from the Excel sheet. So it's kind of small here, but regarding resources, so it says here that we should add 2 resources, a technician and some repair tool. So I copy those, go back to Opus, and I'll go to the table resource, which isn't there, so we do. By the way, sorry, for when I want to insert another table that is not in the model yet, I right click and I do insert table. I was using the shortcut command there, that's how I did it before. But right click and select insert table. And this is a pretty nice functionality. I think you can filter the list of available tables. So if I know that I want to add stuff about resource, I just start typing at the bottom here something about resource, and you see how it pops up there. Okay, so it's the resource, and I also need a table called tossed resource where I connect, if you remember from the presentation slide there, connect resource and tossed resource. Yes, so click OK there and get those tables. And in the resource table, I paste the values for the technician and the repair tool. And we had some additional information there as well. There was an investment cost for the repair tool. So I add this, so there's a price, which is the investment cost for the repair tool. That was an expensive one. And we have an hourly cost of 150 for the technician. So it costs every hour that we use the technician, it costs 150 euros or dollars. Right, and also we have maximum utilization factor here of 0.33. So as I mentioned before, humans typically don't work 24 hours per day. But so here's a way of giving such, this is one way of giving restriction like that, saying that the utilization factor is 0.33, so 1/3. So that means that, yeah, we could only use this resource 8 hours per day, generally. Okay. Sorry. maybe I've talked too much today. Anyway, there was one thing. I actually got a really good question here in the break, and it's if I want to read more, I will need more help when I'm working with this software. Where can I get that? Well, we do have a built-in user documentation, which is pretty extensive, and something that we work with actively to keep it updated. There are different ways of accessing this one. It is together with the installation of the tool in the program files folder. There is a PDF, which is pretty long, but that you can read. But when you're working in the tool, I recommend you to use the built-in help function. So if you see up here, there's question marks and also this one, context help. This one is really good, I think. If I click it here, and then I click somewhere in this table here, you see I will, just because I said it didn't work, but I clicked wrong. But anyway, it's going to open up the documentation, and I hopefully it will take me to, there you see, it took me to this column that I was clicking. So for example, I wanted to read more about the maximum utilization factor. So I clicked with that in this column here on any of the values. So that opened up this documentation file for me for OPUS 10. And as you see, all parameters, both input and output, are listed here, and you can read more about it. So, for example, here, this says something about the column. It also says which tables that I can find this column. So, for example, there's a table called resource station data, and here I can read more about that table. I can see which columns that are included in that table as well. But it's not only the input tables and columns, there's so much more to read in this one. So, for example, you have something called modeling examples, which is a set of sort of tutorials that you can follow. So, if you want to read about how to model consumables, for example, there is an example here. And there are also associated files, OPUS 10 input files, so that you can run exactly the files that are also presented here and discussed in this context. And you can run them and you can test them, and you can same thing if you want to model external demands, FDD modeling, etc. There are a lot of information here regarding that. You can also read more about the model itself. There is a lot to read, and also also some other more overview topics, etc. So there is a lot of information to gain from this documentation file. So I think that's important to mention. Anyway, back to the resources. We had a technician and repair tool, and we also wanted to connect the usage of those two to the tasks. Now we did that in a table called task resource. And if we look here in the Excel file, it said that, okay, so when we perform the remove and replace item, we need one technician. And when we do the repair item, we also need one technician, and as well as sometimes we also need the repair tool. And here it's also given a probability of the usage of that repair tool, which was 70%. Otherwise it's 1. So I'll copy and paste this into OPUS. Okay. And the resource required was 1, and which is the default value here, as you see. But then we also had a probability here of 70% of using the repair tool for when we repair the item. Right? That's really what we need to do. We added the resources, and we just press the calculate button here, and we'll get a new curve. I thought. It was zoomed in there. And you see what happened again. Now this curve has jumped far off to the right because, again, we've added a lot of costs. So it turns out it seems really expensive, actually. But if we select point here, maybe 95% again, same thing here, you see that it's exact same availability. And we want to compare the cost there. So if we run the report, see if you remember, do the same thing for the other one as well. Now we get to report. We can look at this LSC summary figures, and here is without. This one was with the resources, and you see that we have a very high corrective maintenance cost. And also here's a resource investment on 9.6 million. It's the number of resources needed to perform the maintenance. And so OPUS actually calculates how many resources we need depending on how often we perform those tasks that are associated with the resources. And we also get the corrective maintenance cost. But of course, in the other one, here you see that, well, yeah, we don't have any resource investment, and we don't have any cost for corrective maintenance either over the 5 years. So that's why, again, the point is moving far out to the right, because we've introduced new additional costs. Yeah. So if we take a quick look at the same setup in SimLogs, in the simulation, open up the OPUS simplifier and the one with the resources, and so just to show you, this is the one with the resources. Yes, it is. We just go to the control table, and I just do one replication again. So we can study how these resources are used. So so looking at system unavailability here, you see that, well, we don't have any resources here. That's why. You see that after we have all the systems awaiting resources. That's because I forgot to insert the allocation. Remember, same thing as with the spares. If I have the result here for this curve, I'll remove that one to make it. There we go. So I have just one case up here. We have the 95%, and I do this. I right click and do the insert allocation so that I get the results optimized by OPUS 10. I click OK there. We get it. So we have. I just clean that I just clean the stock application file there so that I didn't get the right point in there. So now here we go. So you see here how many also OPUS 10 has calculated that we actually need a lot of technicians and repair tools, etc., to be able to gain this availability here. So right. Yes, so that was the results there from OPUS 10. I just had to add it to the input file. So going back to SimLogs here, saying that we need to just want to see that. Okay, yeah, there we have the resources. So it's with us, and now running the simulation again. Should give us some better results. So now, yeah, actually we don't have to wait for so much resources here, but you see that if we look at the system unavailability part, it's still that we're awaiting items, but the awaiting resources is here. It's the orange one. If I zoom a little bit at the bottom, there might be some parts here that we actually are waiting for resources, which makes the system stand. So if here is another result category Simblocks. Now we can actually study the resources in detail over time as well to see the total. But here if we look over time, you see here that we have a total of 41 resources. They are sometimes available, green. They are in use, so on average we're using like 13 at the same time, or 15. Sometimes they're closed, which is the gray one. You remember we put in a value for one of them. It was the technician, right? It couldn't work 100%. So that's why they are sometimes closed here. Remember, this was just one replication. But for this replication, we also do get some resources that are waiting. So we have maintenance that needs to be performed, but we don't have any available resource at the moment. But as we saw, it didn't seem to be a problem, and this is always what's important. So we see that we do have a queue, because those are items that needs to be repaired, but there is no resource available, so they're building a queue. However, it's not just increasing, it's keeping on a steady level. And also, most important was that we don't get any significant loss of the system availability, because we do have enough spares anyway. So it all always comes down to understand how all these different things impact each other, and that's kind of impossible to understand without the tool. But here we actually do understand that, okay, there is some queue waiting for resources, but doesn't seem to be a problem for the system availability. All right. So that was resources, and we actually have we have time for one more. Let's see if we have one more addition before we wrap up for today. I just wanted to show you also what we call consumables. I mentioned it before. It's about additional entities needed during maintenance, which are not spare parts that we're not optimizing, but we still consume stuff like nuts and bolts and grease and oils, etc. when we perform the maintenance. And this can be a considerable part of the costs, but we don't want it to affect the downtime, because you probably wouldn't let your helicopter stand on the ground because you're missing some bolts. But anyway, we want to know what they cost and how much we consume of them. So with that said, I'll open the same file again, in OPUS, where we started now. This name is getting really long, but anyway, we run that calculation of it, and then I resave it with a different name, and now we add also consumables. Great. So how do we add consumables? Well, it's just as for resources. I do the insert table, and I type consumables, and you see there is a definition table, and there is a table to connect the consumables to the tasks. Click OK. I have those new tables in there. In the Excel file, I probably have some information here about two types of resources, consumables that we want to include into the model, grease and bolts. So I paste them in here, and also add the price and a unit for those. Here is some kind of grease. We buy it in a box, and it costs 220 euros for each box. Okay, and then we have some metal bolts. The price is per piece, so each bolt costs 25 euros. Okay, and then of course we also need to know how much we spend when we repair an item. On average, we consume 1.5 boxes of grease and 20 bolts. So I'll copy these values. I go back to the table called task consumable. Here we connect our repair item task with degrees says takes 1.5 boxes, and then when removing and replacing items, it's on average we require 20 bolts. But not always, because some of the bolts are nice, so we don't have to change them, so it's only 50% where we actually use them. So there's the probability that you can add as well. So that's it. We press the calculate button, see what happens with the costs, and again, we are moving the curve to the right because we're adding costs for this for the consumption of the consumables. 95% here. We have the same spares allocations, but totally different costs. Okay. Now, when we have this, I want to end with showing you some little bit deeper how we can actually do a more interesting cost analysis of this of these two files, for example. So I'm just going to show you the cost analysis tool in OPUS Suite as well. So, and this is kind of easy to do. So I just create a new file here in the cost analysis tool. Looks very similar, but I'm gonna save it. So what I do here is that I can create a cost model that is we have predefined a cost model in this tool that fits with the rest of the OPUS Suite. So under tools here, I can build OPUS Suite cost model. So with a single click, I build the entire cost model here in just a second. So we see how we get this cost breakdown structure. And if you remember from before, I was talking about the sort of the bottom-up approach. And this is exactly what we do. We start from the parameters, the green boxes here. So we're using formulas to calculate the values and then aggregate them up in this cost breakdown structure. So that's how we build up a cost model that is predefined. But now I want to add the data from the OPUS calculations and do more cost analysis here. So I can do that in a pretty simple way here. If I right click, just add an OPUS Suite link. So I can link up the results from the calculation we did. But first of all, I'm going to save this file so that we end up in the same folder. It will make it easier. There we are, and let's call it. So there we go, and now we introduce this link to the file, to the OPUS file. So we have this really long one here, the consumable ones. So add that one, so it's cost related. So we select point number. I'm just gonna look what number. Point had number 16. Okay. So we select that point number 16, and then just click OK, and we run again. Use the calculate button. Save and calculate, and so now I have imported all the values there. 77.141 million. LSC, just going to select the right one here to show you. Hopefully it's the same. Yeah. So here you see the cost from OPUS 10 was 77.155 million, 77.155 million. So it's the exact same total cost, but and then maybe we want to do the same thing for the other, just to be able to compare. So create a new file in catalog. I build that cost model. I insert the there it is. I insert the link to the other file, which was the one without consumables. So it's cost related, selection type point. It's probably number 16 again. So this is just adding that, and then we run it. You just have to save it. In no consumables. No consumables, and run it. There we go. So that's how fast that was. Now we have two different, and that 76.3 1.75 should correspond, corresponds to the life support cost for that one. So now we are comparing, we just have it took me 2 minutes to set this up. So we can compare here. And so what we can do is now to break this up into sub-costs. So for example, here we have the life support cost. So this means that we'll see the CI stands for item investment and CN for, investment cost, and CN is recurring costs. So as you see here, the investment cost is the same for those two scenarios. However, the recurring cost differs. So you can continue to use catalog here, the cost breakdown, to dig down into the details. If I want to look at next level, I just open up it like this, and I see the sub-elements of the cost breakdown structure here to see what's included in the recurring costs. Is it okay there? Turns out that it was one that is really big and the other ones are not so big. You don't even see them. Then we can use the so in the result of catalog, this is a bar graph, but we can look at it as table instead. And you see, so we're looking at a bar graph where something is 66 million and the other ones are 300,000 and 11,000. So it's obvious that one of the costs is very high. That's why we don't even see the others. They are in the bottom here, I guess. So then we keep on drilling in the CNC, corrective maintenance cost. Why is it so high? And we can expand all levels below that one. And we click OK here and open it up. So there is something called pointed here. So it's the item corrective maintenance cost for resources. So that's the part that really, there's something really expensive here for the resources. So so that's how we can drill down to analyze the cost. So I would say the resources here were, what do you say? It's not really balanced in this example. It was so high resource costs. But anyway, other things we can do is also to split up those costs in different dimensions, such as the different materials. If you want to see what materials are driving the costs, we can move it out here, and we see that the most expensive item here seems to be the AB module, and then we can drill down and see why is it expensive. So this is a way of finding the cost drivers. So looking at that, we see that there is very high corrective maintenance costs for the AB module. And I guess this is also due to the use of resources. We're repairing this one quite often, so that's why we need resource quite often as well. But that was just a first glance here at the cost analysis that we can do with catalog and how we can drill down the costs to see the details as well. Of course, we can do the same thing I did for materials here, but we can also look at if I have many different tasks, I can see if there are any tasks that are driving the costs. Now we only have 2 tasks in this example, so not so interesting. But same for resources. How are the costs spread out over the different stations and over time and so on? So, but I'll probably have a chance to show more about catalog tomorrow. But now I think that's it for today. So I just want to say thanks for listening to me all day. Pretty long day, but looking forward to continue tomorrow. So thank you all and have a good evening. Thank you.
빨리 가고 싶은 거예요. 빨리 끝내요. 우리 수리 수준 분석이라고 그랬죠. 로라라는 느낌인데 수리 수준 분석인데 거기에 지금 보여준 거는 수리 수준뿐만 아니라 리소스를 어떻게 알로케이션하고 그걸 최적화하는지, 그 다음에 최적화된 결과들을 가져와서 비용으로 환산하는 것들을 이제 간단히 보여드릴 겁니다. 아무튼 예전에 알고 있는 수리 수준 분석에다가 플러스 알파 해서 리소스 알로케이션까지 어떻게 해결을 해야 되는 건지에 대해서 너무 짧게 했네요. 사실은 상당히 중요한 내용인데 길게 해야 되는데. 아무튼 추가적인 질문이 있으시면 저한테 하셔도 되고요. 아니면 지금 끝났으니까 끝난 다음에 따로 이렇게 말씀하시면 됩니다. 일단 공식적인 교육은 지금 여기서 마치고 추가적인 질문 있으시면 저한테 하셔도 됩니다. 제가 전달을 할게요. 그래서 오늘 일단 여기서 마치고